Okay, so this video, what we're going to look at is we're going to look at the reciprocal functions secant, cosecant, and cotangent function. And we're going to be thinking about their domain, ranges, their type, all that stuff. So let's just talk about it. So when we go to the Desmos app, I have all of it up here for you. So let's look at the secant. Here's the secant. Now, let's take a look at the secant. The secant, if you look at it, I've modified this a little bit so you can see that it goes from, I showed you multiples of pi, but this is the secant graph. Now, notice that looks like we have some horizontal and some vertical asymptotes. My horizontal asymptotes are at y equals 1 and y equals -1. And I wonder why that is. Well, if we graph what's the inverse of the secant? The inverse of the secant is the cosine. And if you can see, this is why we have the horizontal asymptotes. You notice the high and low of the cosine, it appears here. But let's look what happens if we graph this sine. If we graph the sine, I'm going to take the cosine away. If you notice, the sine function, where it is, what do you know? The sine function, uh, what's the use of this guy? Well, if you notice, it looks like there's a vertical asymptote right here. And if I graph x equals, and it looks like it's 1 there, I'm going to go pi over 2. Hey, there's that one. The next one it has is x equals 3. Is it 3 pi over 2? There's another one right there. So it has vertical asymptotes everywhere the sine function is equal to 1. That's interesting, right? That's interesting. So let's see if we can polish this up. So the domain of the secant function, I guess if you really be true about it, is all reals except except all reals except odd pi over 2, right? The range. Well, if you notice, the range is all reals greater than, just greater than 1, or all reals less than -1. Now, one way you can write this is you can write this as union. That's the real fancy way of writing it. What type of function is this? Well, if we look back at what it was, what type of function was it? Well, if we look at it, is it an even or is it an odd? Can we fold this? Looks like I can fold, like right here. It looks like I can fold it and put it in my pocket. So I think we're good with that. So let's let's do that. Let's type that up. The type of function it's an even function. And its period is going to be 2 pi because it is the inverse of the sine, right? It is the inverse of the sine. Now we're going to look at the cosecant. Correction. The secant is the inverse of the cosine. Let's look at the cosecant. Okay, so here's a graph of the cosecant of x. The cosecant of x, what do you notice about this one? I think you could probably see that we still have horizontal and vertical asymptotes. The horizontal asymptotes do occur at y equals 1 and y equals -1. And what I'm going to do is I'm going to just show you why that is. So here's the cosine, right? And then that's its the cosine, and then here's the sine. If you look at the sine, that happens because you can see it bumps. And take away the cosine real quick. It bumps here, it bumps here, because these guys are inverses of each other, right? So that's why these horizontal asymptotes occur. I'm going to take away the sine, and I'm going to put in the cosine. And notice what do you see about the cosine? I mean, I see there is a vertical asymptote here, there is a vertical asymptote here, right? Those are vertical asymptotes, and where do they occur? Well, you could say that it occurs anywhere the sine is equal to zero, right? Anywhere the sine is equal to zero, like pi, 2 pi, anywhere like that. And that should make sense because the sine is the reciprocal of the cosecant. And if we think about its domain, well, its domain, those are our hiccup points, pi, 2 pi, 3 pi, and even in the negative direction if we went that way. What type of function is this? Is it even or is it odd? Well, it looks like it could have rotation symmetry. Like I can't fold it. If I go to the left a little bit, if I go to the left, you can see that it does not, it's not reflection, it's rotation symmetry. So that makes it an odd function. So the domain is all reals except what? Except, it's all reals except um, multiples of pi. Except multiples of pi. The range, well, the range is the exact same thing as the secant. It goes from negative infinity all the way to negative 1, union with 1 all the way to infinity. That basically means everything above 1 and everything below negative 1. The type of function it is, the cosecant, is odd, and that, the type of function it is odd because the sine is also, I believe, an odd function, and its period is going to be 2 pi. Okay? So that covers that one. Let's take a look at the last one. Let's take a look at the cotangent function, which you know is the inverse of the tangent. Okay, so looking at, here's the tangent function. I'm going to just graph the cotangent. Now, if I graph the cotangent, what are some things that you notice about the cotangent function? You have, it kind of looks like, if I graph the tangent, it looks like they've just been kind of flipped a little bit, right? You still have asymptotic behavior, but where are your asymptotes now? Where are your asymptotes now? If you notice, the asymptotes are not where the cosine is equal to 0, but where the sine is equal to 0. And that should make sense because we flipped it, where the cotangent is the inverse of the tangent, so things are there. Now, where does it appear to have asymptotes? Pi, 2 pi, 3 pi. So I guess our domain would be, I guess our domain would be all reals except multiples of pi. So all reals except multiples of pi, which is kind of the opposite. It's a little different than the tangent, which was pi over 2. The range, well, the range is just everything. It goes on forever, so it has no amplitude either. The type of function, well, this is rotation symmetry, so that's odd. And the period is the same as the tangent, which would be, the period is pi. So I hope this explains things a little bit better. I look forward to seeing you in class, and may the force